Okay, so in this video, we're going to briefly talk about our next unit. This is going to be Unit 2 for the semester, and it's called Energy. Okay, so this is the energy unit, and we'll also be talking about things like work and power. Okay, so before we get into this, I want you to think about some different types of energy that exist in the world, and this could be any type of energy that you know off the top of your head. I don't want you to look up answers to this. You can easily look up, all different types of energy, but what are just some types of energy that you know about? So I want you to list all the different types of energy that you just happen to know. And if you miss them, that's fine. This is about what you've learned in your life about energy. Okay, so there are lots of different types of energy. There's kinetic, there's potential, there's thermal energy, there's chemical energy, electrical energy, um, solar energy, wind, nuclear. Um, there's all these different types of energies that we're going to talk about, some more than others. In this class, we're mainly going to talk about what's called mechanical energy, and so that's going to include things like kinetic energy and potential energy and stuff like that. But first, let's talk about what energy is. And energy is a really difficult thing to define. A lot of the time, the definition in the textbook is something like energy is the ability to do work. Okay, well, that's not really a good definition because later on in this unit, I'm going to tell you that the definition of work is the transfer of energy to or from an object. All right, and so that doesn't really tell you anything because then you just have energy and work, and each one is defined in terms of the other one. So I've really told you nothing. And so energy, energy, it's not so easy to give you a good definition of energy. All I can do is tell you that there's different types of energy. It's something that's that can be possessed by an object in many different forms, and that energy can change from one form to another. But as far as we know in the universe, the total amount of energy in the universe stays the same, and that's called the conservation of energy, and we'll spend a lot of time talking about that throughout the course of the unit. Okay, so for now, let's just focus on learning about different types of energy and some properties of energy. Okay, so the symbol for energy is going to be a capital E, and because there's different types of energy, we're going to use subscripts to denote different types of energy. Okay, kind of like how we did with force, right? Capital F is force, but you also have like normal force and force of gravity and force of friction, and so you use a little subscript to denote the different types. That's basically how it is with energy. Okay, the unit for energy, that's what comes after the number, is the joule. It was named after a physicist whose name was Joule, and because it's named after a guy, it is a capital J, just like Newton is a capital N because it's named after Isaac Newton. Okay, so before we get into doing anything too complicated, I mainly want to just talk about the different types of energy that we're going to be seeing and look at some simulations to play around with. Okay, so here is the list of the main types of energy we're going to talk about in this unit. Okay, so pause here, take a look at what it says here. These energies, you're going to have to be able to know when an object has a certain type of energy, and so it would be really useful for you to know the information on this page, kind of like how when we talked about forces, I spent time like laying out like, how do you know when you have tension? How do you know when you have friction? It's the same thing with different types of energy. So for example, you should know that if an object is moving, it has kinetic energy because kinetic energy is the energy of motion. The more motion an object has, the more kinetic energy it has. If it's not moving, it has no kinetic energy. Okay? That's it for kinetic energy. So when we're doing problems later on, you should be able to look at a problem and think to yourself, oh, well, if the car is moving, it has to have kinetic energy. Okay? The second type of energy, actually, before I talk about the second type, so how would we write kinetic energy? We would do a capital E for energy and then a lowercase k for kinetic. Okay, so a little subscript k for kinetic energy. Elastic potential energy. So anytime you have potential energy is energy that is stored, okay, because you have the potential to use it later. Elastic potential energy is energy that can be stored in a spring or a rubber band or something like that, something stretchy. So how do you know if you have elastic potential energy. Well, if the problem says something about a spring or something about a rubber band, then you probably have elastic potential energy. Okay, so these are the context clues you need to think about when you're doing problems later on. And we write that as E for elastic potential energy. Okay, the third type of energy we're going to talk about is called gravitational potential energy. For that, we write Eg for gravitational potential energy. That is the energy that can be stored. It's still potential energy, so it's still stored. Okay, but rather than have to do with a spring or rubber band, gravitational potential energy only has to do with one variable, and that is height. If it has height above the ground, it has gravitational potential energy. The higher up it goes, the more gravitational potential energy it has. Okay, so if you're doing a problem and something is like lifted off the ground, if it's not touching the ground, if it has height above the ground, it has gravitational potential energy. You also have thermal energy, what we call heat. Usually you always generate heat as a result of friction. And you've probably experienced this if you ever like put your hands together and you rub them, like if you get cold, if you rub your hands fast enough, they get really hot. Okay, so friction generates heat. And then work, we'll talk about work later. Thermal energy, I guess we can write ETH for thermal energy. Work we'll talk about later in this unit. That is the transfer of energy. So work is not a type of energy, but it's a way of transferring energy. The transfer of energy. I think that's redundant. To or from an object. Okay, now here is the key concept for this entire unit. As a general, really big deal rule in the universe, all energy in a system is conserved. What that means is if you have a system, like let's say you have like an environment, okay, like a room or a box or a car or some like enclosed system of objects, all the energy in that system is conserved, meaning it stays constant. Now, you can have different types of energy in that system, and they can change from one form to another form, but the overall number, the overall total energy is conserved. And we're going to keep coming back to that key concept throughout this unit. That's called the conservation of energy. Okay, so energy can change from one form to another as long as the total amount remains the same. Okay, so these are the key things we're going to be going with for the rest of the units. So definitely make sure you get these down and you understand everything on this slide. Right now, I'm going to put some links in for two different simulations that I would like you to play around with. And this is just to kind of build your own conceptual understanding. And then on the next slide, I'm going to ask you some questions about the second simulation, the energy escape part. Okay, so the first simulation is about energy forms and changes. And so if you open up that simulation and you go to the tab that says Systems, okay, what you can see is you can put different scenarios just to see a demonstration of how energy can change from one form to another form. So for example, here's a girl on a bike. Okay, she's got some green boxes in her. The green boxes represent chemical energy. Where did she get the chemical energy? Probably from the food she ate. When she pedals, that energy is not destroyed, but it's converted into mechanical energy. Okay, specifically it's converted into kinetic energy because the wheel starts to move and energy of motion is kinetic energy. This wheel turns this other wheel, which is tied to a generator, and that generator is hooked up to a fan, and so the fan starts to spin and it pushes on the air, and so the air also gains kinetic energy. Okay, so energy goes from chemical energy to mechanical energy, electrical energy inside the generator, and then um, mechanical energy again in the fan. And if she pedals faster, the whole thing happens faster. Notice she starts to sweat. She gives off some thermal energy. Now she says, feed me because she is tired. And so if I hit feed me, she gets more chemical energy and she can keep going. And you can play around with the simulation and see different types of energy transformations. So for example, here is the sun, and you can put like a solar panel and hook it up to like a light bulb or something like that and power the light bulb. Again, the purpose of this is just to show you that there's different types of energy and energy can change from one form to another form. And the second simulation is called the energy skate park. And so I want you to open up the energy skate park, and I want you to play around with the energy skate park. You can go to the different parts. Um, I would stick just with the one that says intro, but if you want, you can look at the other ones as well. Playground lets you build your own ramp and put a skater on the ramp and see what happens. Okay, but what I want you to do is I want you to turn on the energy bar graph and the pie chart, and I want you to put the skater on here, and I want you to answer some of the questions that are on this next slide. Okay, so open up that simulation. Take a look at the questions on this slide. Take a few minutes, play around with it. A lot of people enjoy making their own tracks and having the person like fly off and hit the ground. That's lots of fun. Okay, but for now, just stick on that intro slide and answer these questions. Okay, so this should only take you a few minutes to play around with and answer these questions. Okay, so hopefully after playing around with the energy skate park simulation, you're able to learn some things. Hopefully you recognize that the total energy of the skater does not change as they go back and forth because energy is conserved. We just talked about that. Hopefully you recognize that the kinetic energy of the skater um, changes, it increases and decreases as they go back and forth on the ramp, but it is the highest at the lowest part of the ramp, and it's the lowest whenever they stop. And so, for example, here we can see them go back and forth. Their kinetic energy is 0 when they reach the highest point because that's where they stop moving. And then at the bottom, well, I missed it, but at the bottom, they have the most kinetic energy. And it's basically the opposite for potential energy, which makes sense if you think about it because remember, potential energy has to do with height. The higher up you go, the more potential energy you have. But if you're on the ground, you basically have no potential energy, gravitational potential energy. And then hopefully also you recognize that if you add a little bit of friction, that starts to generate thermal energy. And so the total amount of energy still stays the same, but what happens is some of that kinetic and potential starts going away and it starts turning into thermal energy. Okay, we're not changing the overall energy of the skater, we're just changing its form. The total energy is still going to be the same number. It's just now more and more of it's becoming thermal energy. It's becoming heat. Okay, so hopefully you had fun playing around with the simulation. I'm going to go ahead and stop this video now. This was just meant to be an introduction video. In the next video, we'll talk more about different types of energy changing from one form to another. As always, please let me know if you have any questions, and I'll see you guys in the next video.